Today we're doing a lesson on 11.5, area of circles and sectors. So the area of a circle is pi times the square of the radius, or in other words, area equals pi r squared. Well, Fuzzy Wuzzy was a bear, area equals pi r squared, or squared, right? So a sector of a circle is what? It is a portion of the area, typically shaded, so we know which sector, where there's not really a way to name it. We wouldn't call this sector APB. We don't call it that often. Apparently they do that here. Usually if you told me that, I would think angle. So got to be careful with how the language is written there. And again, another fancy way of saying it is the area bound by two radii and their intercepted arc. So, theorem 1110, area of a sector. Well, just like last time, our degree over 360 is kind of the percentage of a circle, right? 90 over 360 would be fraction. It would be the right word. 90 over 360 would be 1/4, right? And then the area then would be typically what we're solving for over pi r squared being the whole area. So, if we had this as our proportion, you would just cross multiply to get the answer on the right, right? If we want the area, pi r squared times degree over 360, and that's what we end up with. So find the area of the red and blue sectors. Well, the red sector has an angle of 120, so we would do 120 over 360 times pi r squared with radius being 14, and you just plug that in. That would be 1/3 of the area, which is 205.25 feet squared. We are square feet because we are now area. Well, area of the blue could be found two different ways. We could do pi r squared minus this, right? We could do the whole circle minus the red to get the blue. Or you could just do 360 minus 120 to get 240 degrees as this side over 360 times pi r squared, pi 14 squared, to get 410.50. You also realize that this is 1/3, this is 2/3, so it makes sense that this is exactly half, or we could times 2 to get that from there. Now, careful with that because sometimes pi rhymes up a little funny like that. Next, we've got, given the area is 214.37 centimeters squared, and this angle is 85 degrees, find the area of the red and blue sectors. Now, we could find radius given this. However, instead of needing to plug in pi r squared, we have 214.37 is pi r squared. So instead of plugging pi r squared, we're just going to plug the area in there. So area of the red is 85 over 360 times that area, and we get 50.62. Area of the blue, again, could be 214.37 minus this, or the other angle, right? 360 minus the red 85 to get 275 over 360 times 214.37 will get you the area of the other part is 163.75. Next, find the area of this, I believe we call it a compound figure? No, composite figure, there's the word. And we've got area of a semicircle plus area of a triangle. Well, the semicircle has a radius what, right? 7 is your diameter. So radius is going to be 7/2 or 3.5. And so I'm going to do pi r squared for 3.5 times half, because we're only half a circle. So pi r squared over 2 becomes pi times 3.5 squared over 2, which is approximately 19.24. This other triangle is a right triangle. So we have base of 7, height is also 7, so half 7 times 7 for base times height is 49/2 or 24.5. When you add those two together, you get 43.74. And again, labels are meters squared. Every time should have a label. Next, if you know the area and radius of a sector of a circle, can you find the measure of the intercepted arc? So think about that for a moment. And so the answer is, right, we're looking for the measure of the arc if we're given the area of the sector of a circle and radius. Okay, if we have the radius, we can find the total area, right? So remember the formula we went over before, back, not that far back, back here, right? We're solving for this piece, and we have this piece and radius. We could have these two pieces and then equal MAB over 360 and just multiply by 360 degrees, right? Cross multiply here to find the arc. So area of a sector equals measure of the angle over 360 times area of a circle. Well, solving for M, right, we've got this, and then you would even multiply the 360 this way. You get 360 times this. So I kind of ruin it with the arrow there. But you could multiply that 360 over to complete how you would solve for it. Next, some complicated finding area ones. We've got basically a target. Find the shaded region. Some might say, well, it's about half the circle. However, because each ring is different radii, right, because we got more than one, each congruent mark is 2. So we've got a circle of radius 2, circle of radius 4, circle of radius 6, circle of radius 8, right? 2, 4, 6, 8. So we'll do the biggest ring first. That radius is 4, and so pi r squared of that would be 64 pi. Ring 3 is 6, and so pi r squared is going to be 36 pi. Now there's a minus because this is shaded, minus the inside gives us this ring. And now we want to find this yellow ring here, the second. So we're going to have to do ring 2 is radius 4, and then we're going to add pi r squared for radius 4 to get 16 pi, subtracting the final inside ring of 2, because this is white, so minus 2 squared pi, which is minus 4, and so we got 64 minus 36, plus 16 minus 4, all times pi. So we're going to get 64 minus 20 is 44, minus 4 is 40 pi, which is approximately 125.66 feet. And that wraps up today's lesson. Let me know if you have any questions.